What's up, 11th grade? Hope you guys are doing well. Hope you guys are all staying safe. So here we go with your other algebra and trigonometry class. Today we're actually going to start with section 6.3 of your textbook. Now there is a previous video of me explaining section 6.3, but because we've been doing this whole block scheduling, I know that there was a week lost between that video and this one, especially because last week you guys were working on your quiz. So I'm going to go ahead and restart the lesson, and this time I'm actually going to explain two examples, okay? So we're going to start on page 447 where I'm going to explain or reteach example number 1, and then we're going to do or move on to page 448 where I'm going to explain example number 2. And at the end of this video, just like at the end of all my videos, I'm going to leave you the assigned work for this class. Now, this week it's going to be a little bit different because we're still doing block scheduling, but so Monday I'm going to upload this video with the class for that day. Then Wednesday you actually have practice problems that have to do with example 1 and 2 that are in your textbook. And then on Friday I'm going to upload the next video explaining the other example. So with that in mind, the topic for today is trigonometric functions of any angle. Now in section 6.2 we saw trigonometric functions of right triangles. In this next section, we're going to see trigonometric functions, but of different types of coterminal or terminal side angles, okay? So there are formulas just like there were for the previous section, but they're not necessarily applied to right triangles, or they're not applied to right triangles. So the formulas are on page 447. I wrote them here. I'm going to kind of brief you on them, and then you guys are going to be able to study them on your own and or pause and rewind the video if you guys have any questions. So this is what, remember, just kind of reviewing angles, this is our terminal side, and our terminal side is represented with a letter R. So if we look at sine, we say that sine is y over r because there's an ordered pair here, x and y, on the terminal side. So we say sine is y over r, cosine is x over r, tangent is y over x, cosecant, which is the opposite of the sine, is r over y, and secant, which is actually the opposite of the cosine, is r over x, and cotangent, which is the opposite of the tangent, is x over y. So let's go ahead into example number 1 and then move on to example number 2. Example number 1, well, they give us a terminal point, so we know that we're going to have a coordinate plane similar to this one. And it's telling us that the terminal side is actually -3 and 4. And they want us to find the sine of z, the cosine of z, and the tangent of z. So the sine of z we know is y over r, but we have x and y, but we don't have r. So to find r is pretty easy. It's just a derivative of the distance formula, which means that it's going to be x squared plus y squared, okay? And we're actually going to substitute our values, and we're going to say r equals, in this case, x squared we know is -3 squared, y squared we know is actually 4 squared, and we're just going to solve the formula. So 3 squared is 9, or -3 squared is 9, and that would be 9 plus 16, because 4 squared is 16, which equals the square root of 25, and the square root of 25 equals 5. So r equals 5, which means that now all I have to do is just start plugging in the function into the formulas. Okay, so if they want me to find the sine of z we know is y over r. So we're just going to replace the y in this case for a 4 and a r for a 5, which is what we found here. The cosine of z is x over r. Okay, and we know that x in this problem is actually represented by -3 and r is 5. So we say -3 over 5. And the tangent of z, which is represented by y over x, in this case y would once again be would be 4, and x would be -3, and that would be it. So that's basically how you do the first exercise. I know I had already done it in a previous video, but I just thought it'd be cool to review it, and so you guys can understand the concept better. So we're going to go on to page 448, so you can turn your books to page 448, yeah, like you really have your books. Anyway, page 448, example number 2, and example number 2 is very similar to this. So when you go to page 448 in your book, on the top left side, they are explaining the quadrants. Remember quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And they're explaining how x and y in the first quadrant is positive, in the second quadrant, x is negative, y is positive. In the third quadrant, x and y are negative, and in the fourth quadrant, x is positive and y is negative, and that also applies to trigonometric functions. That's why, for example, if we look at example number 2, it says the tangent of z is negative 5 over 4, however, that's greater than 0. And in the next example, we're going to start seeing coterminal sides and all that stuff. We're kind of reviewing that just in case. But just so you have an idea, that means that z is probably in the first quadrant, and it's between 0 and 89 degrees or something like that, okay? So with that in mind, they say find the sine of z and find the secant of z. So we're going to once again reference ourselves to these formulas, and we know that the sine of z is y over r, and the secant is r over x. So if we look at this, the first thing that we need to do, and I'm going to go ahead and erase the right side, okay? Example number 1, if you have any questions on it, you can just pause and rewind the video and listen to my voice over and over and over and over. And it's fun. It's fun. I like the sound of my voice. You should too. Anyway, so we know that the tangent of z is represented by y over x. Hence, negative 5 over 4. Okay? So now that I know who's x and who's y, I can find r, and r is found by using the formula r equals x squared, which is, of course, 4, plus negative 5 squared, which is our y. And that's going to be r equals the square root of 16 plus 25, which equals the square root of 41. Now, in your book, they used the calculator and they approximated the value of the square root of 41. I don't have a calculator because my calculator is in my phone, and that's what I'm using to record this video. So what you're going to do now is you're simply going to say, well, start looking for the sine of z. So sine of z, we know, is y over r. So we have our y, which we know is negative 5, and our r is the square root of 41. So if you have a calculator, you can go ahead and find the square root of 41, and that would be your, and 5 over the square root of 41 will be your answer. But since I don't have one, that means I have to rationalize the denominator. Rationalizing the denominator means I'm going to multiply this entire fraction by the square root of 41. So you're going to say the square root of 41, the square root of 41. This is going to cancel out, so, right, the denominator is basically going to be the 41 because the radical signs, it's not that they cancel out, but once you multiply them and you get the square root, you're going to get 41. So we just, a short way of saying it is that they cancel. Okay, so, and then you multiply negative 5 times the square root of 41. And that would be your answer, guys. So if you have a calculator, just find the square root of 41 and multiply by negative 5 and divide that answer by 41. But since I don't have one, I'm going to leave it like that. And then the other one thing that they're asking me to find is the secant of z. Now the secant is actually given to us by the formula r over x. We know that r is actually the square root of 41. And x, in this case, of course, is 4. So we simply say the square root of 41 over 4. And that is our answer, ladies and gentlemen. Again, if you have a calculator, find the square root of 41. Divide that by 4, and that should be your answer. Since I don't have one, I'm going to leave it expressed. And that's it. That's example 1 and 2. And that's it for this video lesson. The work that you're going to do after observing this video is you're going to go to page 448 and you're going to do the first checkpoint, because there are 2, but you're going to do the first one, okay? So that's it. This is, of course, me, your favorite teacher, signing off. So stay safe and hope to see you guys very soon.